So this one is January 2019, Unit 5, last week homework. I'll discuss the question which you sent as a doubt. Question number 4. In this question, two simple harmonic oscillators have the same frequency. The first has a mass of 0.5 and amplitude 30, where its energy oscillated or E naught is there. The second has a mass. The second has a mass 0.25 and amplitude 60 centimeter. What is the energy of oscillation for the second one? So how to work out the energy of oscillation when the mass is attached? Basically, because we are changing the mass and we are changing the amplitude, so we have to drive a general formula which can relate the energy with amplitude and the mass. As we know, the energy is stored like if, and here they did not specify that this is a simple harmonic motion of a mass attached to a string or a mass attached to a spring. So you can use any formula for solving this. But the simple idea is that as we know the energy stored, if I consider this was a spring system. So if this was a spring system, then energy stored E is equals to half force into extension. That is one formula. Or E is equals to, we know F is equals to kx, so it will be half kx square. If I substitute in place of F, we know F is equals to kx. K is a spring constant, so E is equals to half kx square. Now, what is the value of the k? If you remember using a spring system, what is the value of the k? As we know, omega is equals to under root k divided by m. That is the value of angular frequency or omega, which is under root k divided by m. So if I need the value of the k, I will square this equation both sides. So it will be omega square is equals to k divided by m, or k is equals to omega square m. So in place of k, I can substitute omega square m. So if in place of k, I substitute omega square m, so this will become half omega square m into x square. Now, the first one energy is E naught. Basically, we just have to compare. Now, this equation is useful. Now, why this equation is useful? Because in this equation, I can work out what is the effect of mass on the energy, and I can work out or identify what will be the effect of amplitude. The x is refers to the amplitude on. So from this equation, you can clearly see that energy is directly proportional to mass attached to a spring. And specifically why I use this formula, as we know, for an object performing a simple harmonic motion, if it was a pendulum, then length is a factor which affects the time period. So energy stored, what happened, the mass, originally it was 0.5, then it became 0.25. So mass is divided by 2, so energy should be divided by 2. So due to the change in mass, the energy should be divided by 2. And due to the amplitude, it was 30 originally, now they made 60. So it means it is doubled. But this energy vary with the square of the amplitude. So if amplitude is doubled, then it will be 4 times. So what is the overall change due to the change in the mass? It is divided by 2, and due to the change in the amplitude, it is multiplied by 4. So when I solve this, D will be the right answer. Is it clear? Then question 13 and then 15. In question 13, a new hair dryer is advertised as being one of the fastest hair dryers available. The heater in the hair dryer draws a current of 6.75 ampere when connected to a 230-volt supply. Show that the power of the heater is about 1.5 kilowatts. So we know the power is the product of voltage and current. So we'll multiply the current is there and the voltage is there 230 will multiply. We'll get about 1500 watts, which is equals to 1.5 kilowatt. The next part, the air enters the hair dryer at a temperature of 18 degree. That's the initial temperature. The fan in the hair dryer blows the air across the heater at a rate of 0.048 kilogram per second. Calculate the temperature of air as it leaves the hair dryer. And specific heat capacity of air is given. So we know the Q is equals to Cm delta T or E is equals to Cm delta T. So in the question, the rate is given the mass per second. So if I divide this equation by time, that does not make the overall equation will not change. Why the overall equation will not change? Because energy, I divided time both sides. So energy divided by time, that is power. C is a specific heat, mass per unit time. That's also given, and the temperature change, which is final minus initial. So as we are using a hair dryer, the final temperature will be higher and initial temperature will be lower. So first I'm writing T delta T, which is T2 minus T1. So P is the power, which is 1500 watts approximately, or your answer to the previous. The specific heat is given 1.0 into 10 to the power 3. The mass is given, mass per unit mass, which flow per second, that's given 0.048. So we have power, we have specific heat. So we can first find delta T, and from delta T just add the original temperature, the initial temperature T1, you will get the final temperature. State why the actual temperature of the air as it leaves the hair dryer will be less than the value calculated, because when the air is moving or out, that air is not all of the energy is transferred to the air, it is some of the energy lost to the surrounding. That's why the air which is coming out from the hair dryer will have relatively lower temperature as what we calculated. In question 15, the water level in a harbor varies with simple harmonic motion. So explain what is meant by the term simple harmonic motion. So basically acceleration proportional to displacement, and it is both are in opposite direction or directed towards the mean position. So 2 marks, two statement like acceleration proportional to displacement, and then the second mark will be related to a direction is towards the mean position. The second part, the graph shows a variation in a water level in a harbor. So this is a displacement or time graph for 24 hours, means 1 day. Determine the amplitude and the time period of variation of the water level. So amplitude, basically a distance. First what we'll do, if we know the total height and we'll divide by 2, we'll get the amplitude. So maximum it is till 9 and the minimum value is not exact, approximate, like I guess 1.7 or 1.6. So what we will do, it will be 9, because first we'll know this height. So how to know this height? So it will be 9 minus 1.6, 1.5, That will be 7.5, and that 7.5 is the total height. But we know we need half of it, so what we'll do, we'll divide it by 2, so we'll get this amplitude, which will be meter, about like 3.75 meters. Then determine the time period. Time period means time to complete one oscillation or one vibration. So if I take, it's up to you which one you find it easy to take. You can take this interval, the x-axis is a time interval, or you can take the other one. This is about 1800 hours, and this one is, you can take 5800 hours, and this is about 1800 hours. And just subtract the two values and convert into hours. So, or the difference, just take a difference, because actually what they mean, like 600 hours means, if this is 1200 zero, that is basically 12. This one is 6 a.m. This one is 12 p.m. This one is 6 p.m. and this one is again 12 a.m. So take like 5.8. So you can simply convert, like, just to take an interval here in terms of hours you can take and then convert into, because 600 hour here refers to 6 a.m. 1200 hour refers to 12 p.m. 1800 hour refers to 6 p.m. the time interval. Like it's in a 24-hour. Is it clear, this part? Then the next part, show that the maximum rate of change of water level in a harbor, rate of change. So when, how to, it's meter per hour. So what does it mean? It means that we have to calculate the velocity, because rate of change of water level per hour, so it means distance divided by time. Distance divided by time means speed or velocity. So how we can work out the velocity? And maximum, so maximum means you have to find a gradient, means you have to draw a tangent, and that tangent should have a, like the steeper, the one which is a steeper tangent. For this purpose, what you can do, you can work out one or two different positions and find which one is giving you the maximum value. So if I'm taking this one, so this will be, this is 6, this one is 10, so between them it will be 8. And if I took the value, if I take this as 11, so 8 minus 11, that is equals to 3, and the value difference, this will be 8.5, and the other one I'm taking about, say, 3.2. So 8.5, 3.2, so 8.5 minus 3.2, and divided by the interval in hours. So this is like 8 a.m. and 11. So duration here is 3 hours. So divided by 3, you will get the rate. Is it clear, this part? Yes, you can use angular velocity formula as well. If you know, as we work out the time period, As in the previous part, we work out the time period. So using a time period, we can get the angular frequency. Uh, as we know, for one complete the time period, basically theta is equals to omega divided by t. But for one complete vibration or one oscillation, omega is equals to 2 pi divided by t. So we have the time period, we have 2 pi, the constant value. So we can find omega. And v is equals to r omega is there, or amplitude times omega. Amplitude we already measured here. Omega we measure, we multiply, we'll get the velocity. So you can use both ways, you will get the answer. The last part, add a curve to the graph to show that the rate of change of water level in the harbor over a 24-hour. So what we need a rate of change of water level. What is the meaning of rate of change of water level? It means we need a velocity graph, and use the middle of the grid as your time axis, and no vertical scale is required. So we need a velocity. Now, what will be the velocity? Because this is a displacement time graph. What is the function of displacement time graph here? Sine theta, cosine theta, minus sine theta, minus cosine theta. What is this graph for displacement? So it is for cos theta. If I need a velocity time graph, so what simply I have to do, I have to take a gradient. So what is the derivative of cos theta? Because I need a velocity. So that's equal to minus sine theta. So it means the velocity will be equal to minus sine theta. So I should have a sine graph. I should have a sine graph, but minus sine graph. Because if it was a sine graph, it will start with 0 and follow this pattern, but it should be negative sign. This is a positive sine graph, but we need a negative sine graph. So positive sine graph is there. We need a negative sine graph, so it will be this manner. Yeah, we don't have to label in the question. They mentioned that you don't need to label the y-axis, only the x-axis. Already the time interval is there for 24 hours. You will complete for minus sign. Use the middle of the grid as your time axis, and no vertical scale is required. So you just have to. Yeah, the original graph does not start from the maximum one. So how it will affect? Look, the original graph is a bit away from that, but it is showing a function. So even you can work out the points, not exactly from 0, a bit above origin you can draw. Is it clear, this part? Now we'll discuss first the nuclear physics question, as we finished the topic last session, and at the last I will explain and start the last topic, cosmology and astrophysics. Means the quarter difference will be there between them. Phase difference will be about 1 by 4. Okay, nuclear physics question will solve MCQs and the structure questions as well. But first we'll discuss the MCQs and then the structure questions. This is January 2018. Question 5. January 2018, question 5. What could be the right answer for this? A technician is planning. A technician is planning to use a radioactive source to check the calibration of radiation counter, like a GM tube. The source should have a large rate of decay, means it should give out more radiations per second. Select the row in the table which could result in a large rate of decay. So what you want, number of unstable nuclei of the source should be more, so that if more are emitting out radiation, so greater number, and half-life should be shorter. Like within a short time, they tend to emit out all. Like example, maybe you have too many radioactive nuclei, but if it take lot of time, so then the rate will be very slow. That's why C is the right option. Okay, a 4-mark question and a static question. So means your work should be the terminologies which you are using should be according to the topic, the content. So in this question, in an experimental nuclear fusion reactor, magnetic fields are used to confine the hot plasma, and this is to sustain a controlled nuclear fusion reaction. Explain why it is difficult to sustain a controlled nuclear fusion reaction, and so 4 marks. So what could be the reason why we cannot have a sustained, or why it is difficult to have a sustained nuclear fusion reaction? Because basically what happened in a fusion reaction, what you're doing, a lighter nuclei join to form the heavy. So as these lighter nuclei join to form a heavy, first thing what you have to do, you have to overcome the repulsion of the two nuclei. So why the plasma should be kept at a very high temperature? Because you want to overcome the repulsion between the two nuclei, because they will repel each other. So we need an extremely high temperature so that they can or we can overcome the electrostatic repulsion between the two nuclei. And we also need a high density. Why we need a high density for the plasma? So that there should be more particles. So what happens if the nuclei will touch the wall of the container? They will lose their energy, and the temperature or the energy will be lost. And for to do this, we need a very high or very strong magnetic field. So the points when you write here, mention first thing, high temperature is required to carry out fusion. And what is the reason for that? To overcome electrostatic repulsion. Then we also need a high density, so more particles per unit volume, increase the chance of fusion. But what happens when plasma come in contact with the wall or container? It will lose energy, and to confine the plasma within this container, very strong magnetic field is required. So these are some points which you have to include. This is a very common question. You will find this question in different past papers. So a similar trend or pattern is there, writing the answer of these type of questions. In the next question, the graph shows how the mass per nucleon vary for a range of a nuclei. This is a mass per nucleon, not the binding energy, it's mass per nucleon. Explain using a graph how a fusion process is able to release energy. So by using this graph, what we can conclude or what we can say, basically fusion happen for what? Lighter particles join and they form a heavy nucleus. And why it releases energy, or why the energy is released during this process? Because in a fusion we use a low masses nuclei, and what happened, as you can see in the graph, so they will form a high mass nuclei, so mass per nucleon decreases. So if the mass per nucleon decreases, what happened to that mass which is changed? That mass is converted into energy. That is why the fusion release energy. Like here we have more mass per nucleon. At this part, like example, if hydrogen undergo a fusion, it form helium. Helium is having less mass per nucleon. So what does it mean? It means there is a change in the mass, a greater change in mass. So what happened to this mass? That mass is converted into energy, and we can work out by using a formula E is equals to mc square, and calculate how much energy released if if hydrogen changes to helium. Is it clear? This one, that mass per lighter nuclei undergo fusion, then when a lighter nuclei changes to heavy nucleus, the mass per nucleon is decreasing. So if mass per nucleon is decreasing, it means there will be a change in mass, decrease in the mass. So it means what happened to that mass which was originally there but now it's not in the nucleus? So it means that is converted into energy. That's why the nuclear fusion releases energy. Is it clear, this part? Explain using a graph limitation to element suitable for fusion. So what is the limitation here for elements which are suitable to for fusion? Because what happened, as you can see, when we reach the iron is having the smallest mass per, it will have the highest binding energy per nucleon and the smallest mass per nucleon. So to do this, to do the fusion of the heavy nucleus, basically we have to supply energy. Why we have to supply energy? Like example, if I want to if I have iron and I want uranium, from iron I want to undergo a nuclear fusion and I want to produce a uranium. As you can see, from iron to uranium the mass per nucleon is increasing. So how a mass per nucleon will increase? So basically what we have to do to fuse the iron at nuclei, we have to supply them sufficient energy so that this energy can change into mass, so and the mass will increase for per nucleon. So what is the limitation here? The the elements uh, after iron, or which are having atomic number more than iron, it's difficult to undergo a nuclear fusion reaction because we have to supply energy to produce them as the mass per nucleon is increasing after iron. Yeah, in this case, here the energy input will be more than the energy output. So overall reaction become endothermic rather than exothermic. Even you can see here, look what happened even when we carry out a hydrogen fusion. So we have to supply energy. But what we have to supply is small as compared to what is released when this reaction, nuclear reaction occur. For a chemical reaction or a nuclear reaction, there is always an endothermic part and there is an exothermic part. But because for lighter nuclei, the endothermic part, small amount of energy is intake as compared to greater amount of energy released. So overall, it will be exo or release energy. But for elements with a nucleon number, this is a nucleon number, so uranium is 235, so it should be here uh, instead of 92. 92 is a proton number, atomic number. But the same idea is that because what happened, the overall we have to supply energy more as compared to what is released during this reaction. In question 18, a radon is a naturally occurring radioactive gas mainly produced in areas rich in granite. In the open air, radon cause no problem, but it can seep into building from the ground and reach the dangerous concentration. A radon is there, which is 222 nucleon number, decay to polonium, and by emitting alpha particle, complete the equation. So when alpha particle is there or a helium nuclei, the atomic mass, the nucleon number decreases by 4, so this will be 218, and so this should be 86. The proton atomic number decreases by 2 and atomic mass decreased by 4 by emission of this alpha particle. Then the next part, give two reasons why a radon gas in particularly dangerous. So why it could be a dangerous a radon gas? So it is emitting out basically what happened, because if it is present in our surrounding, so we can inhale, like we can intake alpha particle. Look, when alpha particle is outside our body, it's not dangerous. Why it's not dangerous? Because alpha particle is having a low ionization, so even within the air it can be absorbed. But because what happened, radon is a gas which is present in air, so when we breathe in, so this radon will enter, like it will be inside the body and it is having a high ionization power, so that can cause or that can damage the cell. So radon is emitting out alpha particle, it is having a high ionization. The reason why particularly dangerous, so it's emitted out from radon is emitting out alpha particle, and alpha particle have high ionization, that's why it can be dangerous for us. Then the next part, the total kinetic energy of the alpha particle and the polonium nucleus is 5.59 mega electron volt. Calculate the mass difference in kilogram between a nucleus of a radon and its product. So basically what we have to do, we have to calculate here the mass defect. So how we can calculate the mass defect? We know E is equals to mc square. As I mentioned, the total kinetic energy of alpha particle in polonium is 5.59. So this radon producing polonium and alpha, and the remaining what is released, that is the kinetic energy. But that is the kinetic energy of what? That's the kinetic energy of polonium and alpha particle. So what happened, from where this kinetic energy, what is the origin of this kinetic energy? So some of the mass is actually converted into kinetic energy. So we have the formula E is equals to mc square, but this formula is only valid if the energy is in joules. We cannot use mega electron volt or kilo electron volt or giga electron volt. So we have to convert this mega electron volt into joule. So first 5.59 mega electron volt means 5.59 into 10 to the power 6 electron volt will be there. Then we know 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. So we'll multiply this by 1.6 into 10 to the power minus 19 joules. So when we multiply, we will get answer in joules because we converted this electron volt. What is the answer? 5.59 multiplied by 1.6 exponent minus 19. 8.94 exponent minus 13. So that is the energy, and after getting this energy you have the formula E is equals to mc square. So I need the mass, so it will be energy divided by speed. So this energy divided by speed of light square, so 3 exponent 8 square. What's the final answer for the mass defect or the mass difference? That is 9.93 exponent minus 30. So this is the answer for the mass defect. I'll share another link and discuss more questions related to nuclear physics.